In homework 3.1, transformations of graphs, I'm going to help you with a few of them. The first we're going to look at is number 1. And the key here is that we recognize what type of function it is, in this case a quadratic function, and what the transformations are. It was shifted right by 2 and up by 4. On a separate sheet of paper, I'm going to graph the parent function, because if you can't graph the parent function, you cannot graph the transformations. Y equals x squared has a vertex at 0, 0, goes up by 1 in both directions. That's 1 squared. When you go over by 2, 2 squared is 4. So 2 to the right of the vertex is going to be up 1, 2, 3, 4. 2 to the left is up by 4. 3 to the right of the vertex is up by 9. And 3 to the left of the vertex is up by 9. This is a parabola. This is a nice parabola. But this is the parent function. We're going to now be transforming it by making it go 2 units to the right and 4 units up. And the easiest thing to do is to take a key point, like the vertex, and transform it, and use what we know about parabolas to graph the rest. So it's 2 to the right and 4 up. That's where the vertex is going to be. So that vertex is now at 2, 4. Remember that the left and right is backwards from what you would think. And then from there, going both directions from the vertex, 1 squared is 1. 2 squared, so 2 to the right of the vertex is 4. 2 to the left of the vertex is up by 4. That's all we have room for. Another way you could have done it is you could have said, you know it grows by odd numbers. It grows up by 1, then by 3, and that would be fine also. So here is our transformed graph. Let's do the one right below it. Oh, I guess we should finish off by doing the domain and the range. The domain for this, well, it's all the possible x values. So I see arrows going to the left and to the right. The domain is all real numbers. We could also write negative infinity, comma infinity, if we want to do interval notation. And domains are always going to be all real numbers unless you're doing one of 3 things. Taking the square root of a negative, dividing by 0, or taking the log of 0 or a negative. And since none of those 3 things are happening here, we were guaranteed to have a domain of all real numbers, and we can know that even without looking at the graph. The range is the y values, and I noticed that the lowest y value is 4, and then the y values are all going up from there. So I can write it as all the y values between 4 and infinity. It includes 4, so I use a bracket. It doesn't include infinity because you can never get to infinity. Or I could say y is greater than or equal to 4. That's fine too. Okay, let's do number 4. This one we should recognize is a cube root parent function, and so we want to make sure we know how to graph a cube root parent function. What we should know is that there's an inflection point at 0, 0, and then it looks kind of weird. The cube root of 1 is 1. The next cube root you can do is 8. The cube root of 8 is 2. Looks kind of like a square root on this side. When we go negative, the cube root of negative 1 means what times what times what is negative 1. That's negative 1. And the cube root of negative 8 is negative 2. So this is what a cube root function looks like. And you really want to be just like knowledgeable about what these parent functions look like to begin with. So now we need to think about what's happening. I'm going to take this key point and translate it. It's translated 1 to the right and 5 up. So that inflection point, instead of being at 0, 0, will be right by 1 and up by 5. It'll be at 1, 5. This is going to be the inflection point. I also have a multiplier of negative 1. And what that's going to do is it's going to reflect the entire function over what used to be the y-axis. Now, it's going to reflect over what is now the new, I'm going to call it the new y-axis, but that's not great terminology. Instead of going, the cube root of 1 is 1, the cube root of 1 is 1 times negative 1 is negative 1. The cube root of 8 is 2, but negative of that will be negative 2. So we can see how it got reflected going in the negative direction for x. The cube root of negative 1 would have been negative 1, but negative 1 times negative 1 is positive 1, so it ends up here. So we're taking the negative of the cube root values, which is why they end up different than where we might expect. Finally, we've got the cube root of negative 8, so negative 8 to the left. It's not at, notice I'm not at negative 8. This would be negative 8. It's 8 to the left of the vertex. The cube root, 8 to the left of the vertex, will be negative 2. Negative of negative 2 is positive 2. So we get this reflected cube root graph. I'll do one more, just to make sure we've got it. I'm not going to do the domain and range. I'm going to leave that for you. Number 6 has f of x equals 2 to the x plus 1 power minus 3. This is an exponential function. We've got x as an exponent. And so what I'm going to do is I'm going to start by making sure I know what the exponential parent function looks like. It has a y-intercept at 0, 1. It has an asymptote at y equals 0. And then the exponential parent function, 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. We end up having a graph that looks like this. We should recognize our exponentials. So let's look at what's happening here. It's x plus 1 minus 3. This is inside the function. This is f of x plus 1 if f of x was 2 to the x power. So it's shifting left by 1 and down by 3. I actually like starting with the asymptote first. This asymptote usually would be at y equals 0. And that asymptote is going to shift 1 to the left and 3 down. But shifting an infinite line, 1 to the left, is still the exact same line. Shifting it 3 down, however, is going to make a new location for the asymptote. The asymptote is going to be at y equals negative 3 instead of y equals 0. I'm also going to take this main point. I'm going to call it a main point. I like using the y-intercept for exponentials. And I'm going to shift this one 1 to the left and 3 down. So instead of being at 0, 1, it's going to be 1 to the left and 3 down. And that matches up nicely where it's 1 above the asymptote, just like the parent function was 1 above the asymptote. From there, I'm going to follow the asymptote. And over here, remember that 2 to the 1 was 2, and that's 2 up from the asymptote. So 1 to the right of what used to be the y-intercept will be up by 2 from the asymptote. 2 to the right is 2 squared, will be 4. That's 4 up from the asymptote. 3 to the right will be 8. That's 8 up from the asymptote. And the rest will be up the graph. So here's our exponential. All right, I hope that helps. Good luck on the rest of your homework.